Perfect. Good morning, good afternoon, good evening. Thanks for joining this instance of the Antrea community meeting. Today it's Wednesday, the 21st of June. And or if you live in Europe or Asia, it's already summer for you. For folks in the United States, you have to wait a few more hours for your summer. Anyway, jokes aside, for today we have a conversation with Chan on enabling HA for the Antrea controller. This will be HA with the active standby with the multiple controller instances. That is the only topic that we have for today. So Chan, the floor is yours.
Thank you, Salvatore. Let me share my screen. Yes, the topic is about high availability for Antrea controller. Let's talk about the motivation first. As you know, Antrea controller is now responsible for many key tasks, especially network policy and egress calculation, which affects the networking and security of Kubernetes pods. However, currently it runs as a single replica of a deployment of a single replica, and relies on the deployment controller to ensure its availability. But some recent user reports and some tests shows that the deployment controller doesn't provide a very high availability. For example, if when a node that hosts the only replica of Antrea controller becomes unreachable by a panic or some other accident, it could take a long time for deployment controller to create another replica to replace it. And during this time window, this could happen. Network policies do not apply to new ports, and the egresses do not apply to new ports. And for existing ports, network policy and the egress changes will not be applied. This also includes that even a network policy has been applied to a port, but a new ports has been created during the controller's downtime. Then if the new ports should be the phone or two of the network policy, the existing ports will not receive that update. And I think the first two issues may be serious because the ports will not be secured and its egress traffic will not behave like user expect. And I did some tests and investigated why it took so long to create a new replica in this situation. By the way, in other situations, like if the Antrea controller pod crash or you delete the pod, it is very fast to create a new replica. It's just this case. Kubernetes doesn't handle it very well, and the time spent on the failover is first, when a node becomes unreachable, it takes Kubernetes node lifecycle controller 40 seconds to mark this node as not ready, and it will then taint it as no execute. This is determined by the parameter of Kube controller manager, and it defaults to 40 seconds. So we don't have control on this configuration. We have to support that the most common configuration that so we should assume in most clusters, when a node becomes unreachable, and it will take 40 seconds before the node is marked as not ready and has this taint. And after the taint is added to the node, it takes another 5 minutes to evict pods running on this node. This is determined by another parameter. It is the default unreachable toleration seconds. By default, we don't have any toleration. We don't add any no-execute toleration to pods, including Antrea controller pod. However, Kubernetes has a plugin which is enabled by default since a long time ago. It will add no-execute toleration to every pod that doesn't have such toleration already. And the default toleration seconds is 5 minutes. So after the pod is marked as not ready and has the taint, it takes another 5 minutes to delete the pod. And only after the pod, the no responding pod is deleted, deployment controller will start create another pod for this deployment. And it then takes a couple seconds to create a new pod. So that's why in this situation, it takes 5 minutes, 40 seconds and more to fail over. This is what I observed in when I did some tests in kind, but it's different in some managed Kubernetes cluster, for example, in EKS, because when a node becomes not ready, I remember I saw that the node will be deleted soon by, I think it's by the EKS, by some service in EKS. So it will also trigger pod deletions. So the failover is faster than what I observed in kind cluster. In this situation, in EKS, it typically takes about 1 minute to fail over. I guess the first 40 seconds is also spent on detecting this node as not ready. Then there may be about 20 seconds for EKS service to delete the not ready node. So after the investigation, I found that the 5 minutes delay is because of this annotation toleration added by Kubernetes by default. And because it only adds this toleration when there is no such toleration on this pod, we could proactively add this toleration, but set the taint to 0 seconds, 0 toleration seconds, so that once a node is marked as no execute, the pod, Antrea controller pod, will be deleted immediately, and a new replica will be created. So with this change, we could keep, we could reduce the failover time from 5 minutes, 40 seconds to 40 seconds. But even for 40 seconds, it may be too long for some users when they expect Antrea could fail over faster, for example, in just 10 to 20 seconds. So I'm wondering if we could provide higher availability while running multiple replicas. There are two options. One is active-active. This is how Kube API server high availability mode runs. but this is not very realistic in Antrea controller because some factors. The first is that we need to publish the CA certificate, which is generated by the controller itself in most cases. So if we run active mode, we need to make a way to make all replicas to share the certificate key and certificate data. This may be doable, but the second is more challenging. This is because like Kube controller manager and Kube scheduler, we have some modules that can only run singleton without big change. For example, the nairobi status and the stats aggregation. We need a single place to aggregate this data. So it's not very feasible to make this feature work in active mode. And there are some other functions like external IP pool and IP pool IP allocation. It is very complicated to achieve this when multiple instances could do the same thing. And also including the traffic flow tag allocation. And the third reason is that today we didn't see any problem except the high availability by running a single replica. It is the performance of the single instance is good enough to support a large scale cluster according to the test. So except for the HA, I think a single active instance is enough from our architecture perspective. So another choice we have is running multiple replicas as active standby mode, just like Kube controller manager and Kube scheduler. And then there are two problems we need to solve. The first one is how we do leader election. The second is how we route the service traffic to the active instance. Yeah, I will talk about the solutions in this page. For leader election, like Kube controller manager and Kube scheduler, we could leverage the Kubernetes mechanism. There is a lease API, which is designed to be leveraged by this library to support leader election, and it is very easy to integrate this library to have a leader election in Antrea controller, and the parameters can be tuned so that the failover can happen in 15 seconds or less. By default recommended parameters, it normally takes around 15 seconds to 20 seconds to select a new leader. But the challenging part is the service traffic routing, because we have only a single active instance, and we want to make sure clients of Antrea controller, including Kube API server itself, and Antrea agent, and external and control clients, we need to ensure the request only reach the active instance. But if we just do nothing and scale up the replica number, all of the instance could receive the request and the standby instance do not know how to handle the request. So I investigated 3 ways to make it work. I learned the first one from internet. However, I think this may not really work. I will explain it. The essence of this approach is that we should add one check to Antrea controller Redis probe, so that only active instance will return true for ready, and the standby instance will return false for readiness probe. Then in Kubernetes API, only active instance will be ready, and the other instance will be not ready. And the service will automatically select the only ready instance as the endpoint of the service. And the traffic could be redirected to the active instance. The benefit of this mode is that there's no extra operation cost. Everything is the same despite the number of replicas. It could work with 1 replica, and it could work with 3 replicas. Nothing needs to be changed when we switch modes. But the drawback is that first, the deployment status will look abnormal because its ready replicas will always be less than its desired replicas, which may confuse some monitoring tools. And even when we run kubectl rollout status, this deployment, the command will never finish because it will always appear as progressing. But the biggest problem is that it relies on ready condition of port. If a port crashes or it is killed, the ready condition will be changed to not ready immediately. But it's not the case when the node becomes unreachable. This has the same issue as the deployment controller, because when a node becomes not reachable, the port will only be marked as not ready after this period. So if we adopt this approach, it's almost equivalent to running a single replica. Maybe it could reduce a couple seconds to create a new port, but I don't think it's very worth to get that little benefit by adding this logic. So I tried another solution, which is to make the service, Antrea service, without to change the Antrea service to be a service without selector. This means that Kubernetes will not be responsible for calculating the endpoints of this service, and we will do it ourselves. And we will ask the active instance to update itself as the only endpoints of the service proactively. This should reduce the delay of failover to about 15 seconds or less if we want, because as long as a new leader is elected, it could immediately update itself as the endpoints, and the traffic will be immediately redirected to that port. So it's the fastest solution. However, my only concern is the operation cost, because by default or before we make this feature officially supported, we have to switch. We have to change the service definition when running different modes. For example, if a cluster is already created and has run Antrea as a single instance mode, it already uses service definition with a selector. But if user want to change to another mode, they will have to change the service definition to remove the selector. And I tested that by changing the service, the existing endpoint slice previously created will not be deleted automatically. But this must be deleted, because when the active instance of Antrea controller update itself as the endpoints of the service, it will be mirrored to endpoint slice, but it will not remove the existing endpoint slice. So two endpoint slices will be both used by queue proxy or Antrea proxy to receive traffic, which will cause a problem. So we need to be careful to ask user to upgrade or change the HA mode when it is in a existing cluster. Yeah, and there is also some other approach I saw from the internet. Someone use this approach. They add an extra label to the active instance. For example, they add this label to the active one and make the selector to select only active port by matching this label. But I think that it is essentially not very different from the second one, except that it is a bit more complicated, because the active instance will be will need to also remove this actual label from previous active instance, which is hard to guarantee the transaction in Kubernetes when you are operating several objects. So I think this it's not better than the second one. Yeah. And so my plan was, my plan is first we should consider setting a no-execute taint with 0 toleration seconds to Antrea controller. This may be a big improvement to most clusters that are not self-managed Kubernetes cluster, and may be helpful for some cloud managed clusters. For cloud managed clusters, maybe the failover time could be reduced from 1 minute to 40 seconds. And another plan is to implement the second approach to support active standby mode. But because of the operation cost, in the first stage, I want to make this feature experimental, and we just provide another manifest in which Antrea service selector will be empty and the deployment replicas will be 3. And we could also provide a Hellman value. For example, HA equals to 2, and while which the above values will be automatically set. And if this mode turns to be working great, I think we could consider that we change the service selector to empty, to always set to empty. But if the replicas is 1, and the only instance will still be responsible for updating itself to the endpoints of selector, so that in the future, user could switch between the singleton mode and active standby mode more gracefully. Yeah, that was what I got today, and I'd like to answer your questions if there is any.
Thanks, Chan. That's been a very thorough presentation as usual from you. And well, let's go to the question section. So if anyone has questions, comments, concerns, ideas, please go ahead.
Chair, question: have we received any requirements from users? They want to have a shorter failover time than 40 seconds.
Yeah, I brought up this because last week we received a user request that they observed 1 minute failover time in EKS. Yeah, but I haven't checked whether 40 seconds works for them.
Well, what's their expectation? They want less
shorter. They didn't mention how short it should be, but because of the second delay, I assume that it may have some impact, more or less, even on cloud. Even though the cloud could delete unreachable port. So I will first try to suggest them to update the deployment manifest to add a 0-second toleration seconds, so that the port could be deleted immediately, and see whether the new time could meet their requirement. Yeah.
Okay.
I think that the only comment that I have is, is probably trying to find whether the effort for supporting these might be justified by the benefit that we give to our users. And I was considering one aspect, and when we do things like reducing the default unreachable toleration seconds from 300 to 0, what we are going to get are often false positives. So what is the cost of a false positive, in my opinion? If I remember correctly how the Antrea controller works, since there aren't many initialization tasks that need to be performed at startup, the cost of failover is pretty much just the cost of destroying the old pod and creating the new pod. So let's say even if we have some false positives, it's not going to cause a big deal. Is that correct?
You mean after removing this toleration seconds, if it happens frequently, the pod is deleted and recreated? You mean the
yeah,
actual...
I mean, we don't know how frequently it will happen, but I'm just wondering if we have some false positive, like a failover is triggered, but actually it just the node was unavailable just for a couple of seconds, right? So in that case, are we going to pay a penalty for initializing new Antrea controller, or does the new Antrea controller comes up immediately and it's able to operate?
Yeah, I think it takes only a few seconds to come up a new instance. There is no many cost to initialize it, and besides, it's not like the port becomes unreachable immediately. We will delete the port. First, there is still a 40 seconds duration for Kubernetes to tolerate the node's response to be unreachable. Only after it becomes unreachable for 40 seconds, and during which it receives no any status update from that node, it will mark this node as not ready. So if it's just a few seconds unresponsive, I think this will not even trigger this process.
Okay, thanks. Understood.
So there's one question like how the synchronization of state will take place between active and standby. Let's say I have changed something on the active controller, right?
Sorry, can you repeat the question?
My question was like there is some changes on the active Antrea controller. We are using active as standby mode, right? So
Yeah.
So that will be like, will there be any database, something kind of maintained, which will also allow the standby controller to synchronize with active?
No, we don't need to. The only storage is Kubernetes and etcd. When a controller runs as a standby, it basically does nothing but to but tries to acquire the leads from leads API, and only after it acquires the leads successfully, it will promote itself as the leader, and it will then to do the other things we have in controller. When it runs as a standby, it doesn't do the and it doesn't run any controllers or modules. And
Okay,
because
so
the storage is the Kubernetes, after the active instance is done, the data is persistent in etcd anyway. So the standby instance could retrieve the same data.
okay, so yeah, another thing is like we are going with the active standby, not active. So active have advantage like you can distribute traffic over active, and it can be can act as a load balancer. But in this case, only one controller can be active. So that advantage we are kind of will not be having an active standby.
Yeah. As I explained in this page, there is some architectural problem that is not easy to resolve if we run active mode. And perhaps according to our test, perhaps one instance is already enough to support the load.
Okay, fine. Then we are going with active standby. Yeah. Thanks.
Hey, Chan, a quick question. I may have missed something. Can you go back to the different options for the service traffic routing? Thank you.
Yeah.
So for the option you have in red, which is your preferred option, did you mean that you wanted to have like different service definitions for the case without HA and for the HA case?
Yeah.
Why don't we use the same mechanism for the regular case? I mean the no HA case.
Yes, I did plan that in the future, if this HA mode tends to be working fine, and we could unify it. But currently, if we make the change immediately, it could affect the existing users who upgrade from a previous release, because some endpoint slides will not be deleted by default, and my major concern is backwards compatibility. Yeah, how and whether this is a really good solution to support HA. So I would prefer to have a different definition and using a different YAM to deploy Antrea HA mode and to see whether it proves to be working fine. Do you have
This could be-
concerns?
No, I have no concern, but just for my ignorance, isn't the readiness probe enough? Like this, if a pod is not ready, should it be removed from the service endpoints, making sure that only the active instance is a usable endpoint?
You mean the first approach?
Yeah, the first approach with the pod readiness, basically, the only ready pod which is ready is the HA, is the active one, right? All the
Yeah,
others
but
are not ready.
the problem is when the previous active instance node becomes unreachable, it takes this time for Kubernetes to mark that pod as not ready. It will not be updated immediately when the node goes
Okay.
down. Yeah.
Okay, no, because I was under the impression, maybe I got it wrong, that you were implementing a new readiness probe where only the active pod will return as ready. And but I see your point, because before doing the transition, okay.
Yeah, because
I
even
think I see your point, because
Kubernetes is not even running, so it will not even call this
no,
readiness.
because I was mistaken, because I was thinking that the leader election will kick off immediately, and the leader election will select a new leader, and then the readiness probe will return ready only for the leader. So regardless of the node status, of the node unreachable status, I was thinking that all the pods that were not elected as leader were returning not ready.
Yeah.
So I misunderstood, I believe.
Okay.
And did you find another solution using that that red solution, the second solution? Sorry, that wasn't clear. Did you find another project using that second solution?
No.
No.
Yeah, what I searched is the first and the third one, but the Kubernetes API server itself uses the second one, but for a different reason. Kubernetes Kube API server will report itself as the endpoints of the Kubernetes service, but the main reason is before itself is ready. I think Kube Controller Manager is not even able to update the API.
Mm.
I'm not sure what's the root cause, but yeah, it uses this mode. It append itself as the endpoints, but in our case, we replace the only endpoint. Yeah, I didn't find another project using this mode because in I haven't seen a project which is similar to our architecture, that the Antrea controller is responsible for both API and controller.
Mm.
If we divide the responsibility, I think we could run the API as active mode and run some controller in active standby. That would be fine. The problem of the first approach is the first approach many projects adopts is that it doesn't even resolve our problem. It still takes this long time to fail over, even there are multiple instances running at the same time.
Yeah. I mean, the second solution sounds fine by me, as long as in the long term we can have a unified approach for HA with, I mean, for a single replica case and a multiple replica case.
Yeah, I think that would depend on how this approach
Works,
works.
performs.
Yeah. Yeah, if there's no other questions, so I think that it is.
Okay, thanks, John. That's been a great discussion for today. So we still have some time in the scheduled time for today's meeting. Is there any other topic that you would like to bring up for discussion? I'll wait for like about 20 seconds as usual for you to come up with a proposal. And time's up for today then. So I would like to thank everyone for your time and wish everyone a good night, good evening, or a good afternoon. And to the team members in China, I would like to wish a great long weekend for the Dragon Boat Festival. So see you in 2 weeks' time and have a good one.
Thank you. Bye.
Thanks.
Cheers.
Thanks,
Bye-bye.
bye.